everyone. Thanks for inviting me, and it is my pleasure to address on this to this wonderful group of people with diverse background, people from academia, industry, policy, and I think the experienced scholars are already present and already joined in this event. And I can see it's more than 80 people have joined, so it's a highly successful event. So a big round of approach for Professor Mangeram for organizing such a wonderful event. And for giving me probably 10 to 15 minutes, let me start with my theme, with my topic, which I would like to discuss. कैसे स्क्रीन शेयर करते हैं, कैसे करोगे? अच्छा, please. Is the screen visible, please? Anyone? Srishti?
Yes.
Yes, it's visible.
Yes,
So like, thank you so much. So like it was mentioned in my introduction, as per my expertise, I'm working in this circular economy, sustainable operations management, dealing green issues in this supply chain and operations management context, and with a kind of engineering background. So I'm more inclined towards these decision-making simulation and applying those mathematical modelings in the area. So I would like to be very brief, probably in next 10 minutes with my insights. This particular research which I'm going to discuss, so this was sponsored by Turkish government, and when I was recognized as a visiting scientist there somewhere in 2019 and 2020, still I'm working with those people, and we are working as a team, and I think it was a wonderful journey that we have developed a couple of nice contributions from this particular collaboration. So in this particular next 10 to 15 minutes, I will discuss something about optimal number of times for remanufacturing. So, for example, I would like to start with this very catchy word called circular economy, because when people are talking about, let's say, linear economy, so initially we were there in the linear economy, like we were just taking those resources and we were producing those, and then finally, as a customer, we are consuming, and as a once we are using them for their end of life, so finally it is going to become a waste. But like these days we are living in a resource scarcity age, like where the resources are finite. So we can see the problems, for example, these environmental pollution, or it could be climate change issues, global carbon emission issues, or there are so many other issues related to water, air, or maybe the earth planet, that we have to save our planet. So the thing is, like, this is the high time probably we need to think about how we are going to make a sustainable future. And as a business management community, and as a mathematical, you could say mathematician kind of background, so we are using those OR models, we are using those optimization stuff, but is it really need of hour that we need to apply such techniques probably, or such an expertise basically to help our communities? Because at the end of the day, we have to build sustainable communities. We have to build communities like where people can live and where we can probably go for prosperity at our planet. So the thing is here, like in the circular economy concept, we are talking more about like why not to treat this waste as a resource. And when we are treating this waste as a resource, so how we can recover the value from this waste. And when we are treating this waste as a resource, or when we are recovering the value from this waste, so there are different strategies. For example, it could be reuse, it could be repair, it could be remanufacture, it could be recycle, it could be rethink, it could be redesign, it could be reduce, it could be refurbish, it could be recannibalization, or it could be some other strategy. So in literature, if you will see, so there are different strategies, different models are available, how you are going for implementing circular economy at a business context. And when we are talking about this application part, probably as a mathematician, so we need to do that kind of analysis. Either we are doing those statistics, or we are building some AI algorithms, or probably we are going for some kind of decision making stuff, or probably we are going for some kind of optimization stuff. So how probably we are going to optimize the performance of the whole system. So I think there probably we can contribute to the society, because see, building those backgrounds, building those models, it's fine, but what is the real implications models for the society? I think this is going to make a real impact. So as a researcher, probably we need to think about those impacts, like how we are going to improve our community. So I'm going to discuss probably maybe next 5 to 10 minutes about this particular research. See, We are talking about remanufacturing, but there is a limit that how many times probably a product can be remanufactured. Because when you are talking about remanufacturing, so as a customer, I think sometimes we are not bothered, or probably we are not happy to buy those remanufactured products, because we have that kind of impression that the quality is not good, or probably sometimes you don't have that kind of performance, you don't have that kind of trust. So that's why a company, when they're going for remanufacturing, so they need to build that kind of trust among customers so that they can buy those products, because otherwise they would like to buy probably those fresh, or probably those you could say virgin material products, because of high quality, and as well as they can afford them as well, because the sustainability and circular economy is there in our roots in India. For example, if we have two brothers or sisters, so probably the clothes of one could be used by another, or the books of one could be used by another. So the thing is, like in our culture in India, we already are doing with this sustainability or circular economy. The thing is now we are following the Western culture, and probably we have just missed that trick, that already we are doing very good, and probably we need to, you could say, lead the wheel, that already we are doing very good in this remanufacturing, or probably this circular economy and circular sustainability kind of stuff. So what I'm going to discuss here, that when we are deciding to go for remanufacturing, so there is a limit that how many times probably a product could be remanufactured. So this is something I would like to skip. Probably I would like to directly start from here because of the shortage of time, because I have been given only 10 minutes. So remanufacturing, what is the benefit? It can save energy, it can save labor, it can save raw material, because we can understand the importance of saving raw material or the fresh material, because it's the resources are finite. So but the thing is, then when we are talking about remanufacturing, so we need to talk about the quality, and we need to talk about the costing issues, because otherwise if a company, they are uh, expending, or probably the expenditures are more than this real production, so why they should go for this kind of remanufacturing stuff. So that's why it is important to make a trade-off between when probably how, or probably how much time probably we have to go for remanufacturing in a company. So that's why we have to think about that. For example, paper, so we can go for recycling about 5 to 7 times. Glass and metal we can recycle infinitely, but for example this plastics or maybe aluminum and those things, we can't go for recycling them, or maybe remanufacture them infinitely. There is a limit, there is a number, because we have to take care of the quality and as well as cost. In this particular research, we have talked about basically 4 research questions, like how many times a product should be remanufactured, what are the parameters, those are going to affect that. In that case, what about this remanufacturing rate? In this remanufacturing rate could be considered as a linear function. So in the previous research, it was not considered as a linear function, but here in this research, we have considered it as a linear function. In the future research, we are trying to take it as a non-linear function. And then we have seen the impacts of these parameters to calculate the optimal number of times for remanufacturing. So this is something about the gaps, let's say the challenges addressed. So there is a disposal rate, because you can't remanufacture 100%. So something you have to dispose. We have taken this optimal number of remanufacturing, that how many times probably a product can be remanufactured, and this remanufacturing rate beta tau is considered as a linear function. Okay, so this is the model that I would like to show it you quickly. So this is something like when we are going for production process. This is something when we are going for finished products. So here in the market, there is a demand. Okay. So when we are going for this recycling, or probably remanufacturing, or probably we are going for that kind of mechanism. So we are taking this alpha plus beta epsilon into D. This alpha is something called as alpha into D is called a disposal. And then this beta epsilon into D is called as how much you can remanufacture, and then it is entering in your production process. So you are using some of the parts, some of the friction for remanufacturing, and some of the fresh material you are using because it is impossible to remanufacture 100%. Okay. Now, if I talk about how we have taken this problem, so initially there was a contribution made by Professor Tanter, where they have talked about lot sizing, where they have talked about minimizing the cost. Then another contribution was made by Professor L. Sadani, where they have talked about beta is always fixed, beta was remanufacturing rate, and they have talked about it is not taken as a linear function. But in this particular research, we have taken 3 parameters. So beta was considered as a linear function, because we can't take it as a fixed value, because there is always, it is changing with time. And then mathematical formulation was done for this optimal number of remanufacturing time, and disposal rate was also taken as a variable per unit time. So if I talk about the different notations for the model, so it was D called as demand. We have taken setup manufacturing setup cost. SR is taken as remanufacturing setup cost. VM is taken as manufacturing variable cost. VR is taken as remanufacturing variable cost. Beta epsilon is taken as remanufacturing rate at time ups. This tau beta is taken as remanufacturing rate. A and B has been taken as for that regression coefficients and regression line. Coefficient X is taken as number of remanufacturing. So this was the more or less the parameter that we have considered. Now, if I talk about the model formulation, so this was the mathematical equation that we have applied, and we have modeled the function. So the objective was how we are going to, you could say, minimize this total cost. So this was the goal function, because the total unit cost should be minimum when you are going for remanufacturing, because otherwise there is no point to go for remanufacturing. So I will directly skip all these points, because otherwise it will be taking too long. So the thing is, like, this was the mathematical formulation, and the final equation that we have derived, it was a second order polynomial. So minimum positive roots have been taken, and finally we have done with the simulation. I will show those things with you. The case study we have taken, as this research was conducted in one of the company in Turkey. So I have also personally visited the company, and they are highly engaged in this manufacturing initiatives, and they were a bit involved in this PVC window manufacturer, and the different products that they were dealing with: PVC window, door, and shutter system, and so and so. So they were involved in this manufacturing initiatives. And this was the simulation setup that we have developed. We have used this Java language, and different simulation experiments were performed, and it was around 2.2 million simulation scenarios were generated by using different range for demand, manufacturing setup costs, remanufacturing setup cost, variable cost, and remanufacturing variable cost. So this was the all solution approach. The program was written in that way, and we have modeled this with a condition, like if the ORT, it increases the maximum product life cycle. So it is not possible. If it is not exceeding the maximum product life cycle, so then we are going for remanufacturing till that level, because it is not making any sense if this ORT is going to be increased this product life cycle. Okay, so I'll skip it, and this is the code that we have provided. This was the code that we have written in that Java language, and let me directly come to the results. So basically we have come up with a couple of results. Like, we have identified the effect of demand on this tau, like when, like, number of times the item is recovered. So we have seen that ORT ranges from 7 to 10 years, when the average demand is going to be equal to or greater than 7,000. And if you are talking about the effect of this ORT on this, you could say the manufacturing cost. So you can see, like, when it reaches certain level, for example 70,000, so almost it becomes constant. So in manufacturer, they have to be a bit conscious, like, about these numbers, like, because if there is no effect of that manufacturing setup cost in that, so in that case, like, this tau is going to become, for example, for 9 years. So in this particular research, like, we have modeled this ORT with different parameters with respect to demand, as I have discussed with you, with respect to this manufacturing setup cost, with respect to this remanufacturing setup cost. So there was no relationship was found between remanufacturing setup cost and this ORT, like optimal number of remanufacturing. However, there was a relationship was found between variable cost, because variable cost, which is changing with time. So it was a straight line, like it was a positive relationship, and then it was a negative relationship. Optimal remanufacturing times, and between this manufacturing variable and remanufacturing variable cost. One interesting finding, when we are taking an effect of VM minus VR, like manufacturing variable and remanufacturing variable cost. So we have found this fracture point. So the break-even point to the fracture was occurring. So when the difference between this VM minus VR was 15, and the reason is, like, because it is a point when VM minus VR is crossing this SR. SR is setup cost of remanufacturing, and which was set up as a condition that setup cost of remanufacturing could not exceed VM minus VR. So that's why there was this fracture. That's why there was a break even that was occurring in the system, and as a manufacturer, we have to take care of that fracture. So at the end, I would like to discuss with the conclusions. So the thing is, like, when we are going for remanufacturing, it is a wise decision, but there is a limit. You can't go for infinite times. So you have to be very conscious, like, which product probably you are going to be remanufactured, which material you are going to be used, and how many times you are going to remanufacture that, because you have to take care of the quality and cost. Otherwise, as a manufacturer, as a business organization, it is not a wise decision, because you are doing something for your profits as well. And as a customer, we are not going to buy those products if they are not of good quality. So the quality level is also very important. The parameter which we have taken, so we have taken manufacturing setup cost, remanufacturing setup cost, manufacturing variable cost, remanufacturing variable cost, and the remanufacturing rate has been taken as a linear function. It was not taken as a fixed value. And at the end of the time, difference of this VR minus VR is going to determine this remanufacturing times directly. So in that way, I have provided the conclusion. And the future scope, we are trying to take it as a non-linear function. We are trying to integrate industry 4.0 to take the real-time data. Some of the other parameters could be added, sensitivity analysis could be added, and we are trying to think on further insights on this particular thing. So I tried my best to keep it very short and crisp and very precise. I can understand within 10-15 minutes, it might be difficult to understand what was